In this episode, we move into the part of audit work where planning turns into proof, because an auditor eventually has to do more than understand a process and ask good questions. A Certified Information Systems Auditor, CISA, candidate needs to understand how testing works and why sampling is such a central part of that work, especially in environments where thousands of transactions, accounts, approvals, and system events may exist. New learners sometimes imagine that a strong audit means checking every single item one by one, but that is rarely practical and often not even necessary to reach a reliable conclusion. Audit testing is about gathering evidence in a disciplined way so the auditor can decide whether controls are designed well, operating as intended, and supporting business objectives. Sampling methodology becomes important because it helps the auditor examine part of a larger population in a way that is sensible, fair, and supportable. The goal is not perfect certainty. The goal is reasonable assurance based on methods that are thoughtful enough to justify the conclusions placed into the final report. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Audit testing begins with a simple but very important question. What exactly is the auditor trying to prove or evaluate? Testing is not random inspection, and it should never become a routine activity performed only because a checklist says a certain number of samples must be reviewed. Every test should connect directly to an audit objective, a risk, and a control or process the audit is meant to assess. If the audit objective concerns whether access to a payroll system is approved properly, then the testing should examine evidence that approvals occurred, that they were performed by the right people, and that the process covered the full period under review. If the objective concerns whether changes to a production system were governed appropriately, the testing should look at approvals, testing records, segregation of duties, and implementation evidence. This connection between objective and test matters because a technically correct test can still be the wrong test if it does not answer the real audit question. Strong methodology starts with relevance, because evidence has value only when it helps the auditor reach a conclusion that actually matters. One of the most useful ways to understand audit testing is to separate the idea of design from the idea of operation. A control may be designed well on paper, meaning the process appears capable of reducing the risk it was meant to address, but that alone does not mean the control actually works in daily practice. A manager approval step may exist in a documented procedure, for example, yet staff may routinely bypass it when deadlines are tight or when the system allows informal workarounds. Testing design means asking whether the control, if used as described, would reasonably address the problem. Testing operation means asking whether it is consistently happening by the right person at the right time and with enough quality to matter. Some testing also looks directly at outcomes, such as whether transactions were accurate or whether invalid entries were prevented, even if the focus is not on one single control. For beginners, this distinction is valuable because it explains why auditors often review documentation first and then test real examples from the process rather than assuming written procedures reflect reality. Before sampling begins, the auditor usually needs a good understanding of the process itself, because poor understanding at the front end can make even careful testing meaningless. This often starts with inquiry, observation, documentation review, and walkthroughs that trace one or more examples through the process from start to finish. A walkthrough helps the auditor see where decisions are made, where approvals occur, where systems enforce rules, and where human judgment enters the workflow. It also helps identify the population that will later be tested, which is a foundational step in sampling methodology. If the auditor does not know whether the relevant population is all user access changes, all terminated employee accounts, all purchase approvals over a certain amount, or all system changes during a defined period, then the testing may drift away from the objective almost immediately. Good methodology, therefore, depends on good process understanding, because sampling is never just a math question. It is a question of whether the items being selected truly represent the activity the audit is supposed to evaluate. Sampling becomes necessary because organizations generate more activity than an audit team can realistically examine item by item, especially when time, staffing, and cost matter. A large company may have thousands of new accounts, hundreds of system changes, or an enormous number of transactions during the period under review. Reviewing everything could take so long that the audit becomes impractical, expensive, and too late to provide useful assurance. More importantly, checking everything is not automatically better if the testing is poorly targeted or if the population itself was not defined correctly. Sampling allows the auditor to select a portion of the population and use the results to support a broader conclusion, provided the method is appropriate for the objective and the limitations are understood. New learners sometimes mistake sampling for cutting corners, but that is the wrong way to see it. Sampling is a disciplined way to manage limited audit resources while still reaching reasonable conclusions, and it is common in audit because good assurance depends on intelligent coverage rather than on sheer volume of review. A key part of sampling methodology is defining the population correctly, because a sample can only be meaningful if it comes from the right universe of items. The population is the full set of items from which the sample will be drawn, and it has to match the audit objective in a very precise way. If the audit is evaluating whether all terminated employees had their system access removed promptly, then the population should be all relevant terminations during the review period, not all active users, and not only the cases that happen to appear in one manager's records. The auditor also has to identify the sampling unit, which is the individual item being selected, such as one access request, one invoice, one account, one change record, or one log event. Completeness matters as well. If the source list used for sampling is incomplete, duplicated, or poorly filtered, the entire testing approach may be compromised before a single item is examined. That is why experienced auditors spend real time validating the population and not just jumping straight into sample selection. Once the population is defined, the auditor has to decide whether to use non-statistical sampling or statistical sampling, and beginners should understand that both approaches can appear in real audit work. Non-statistical sampling relies more heavily on professional judgment when deciding how many items to review and which items to include. This method is often used when the population is small, when the audit objective is narrow, when items are highly similar, or when the auditor is focusing on areas of particular concern rather than estimating a precise rate of error. It can be practical and entirely appropriate when handled carefully, but it also places greater responsibility on the auditor to explain why the selected sample size and selection method were reasonable. Statistical sampling, by contrast, uses probability-based concepts that allow the auditor to draw more formally structured conclusions about the population. The important beginner lesson is not that one method is always superior. The real lesson is that the method should fit the objective, the risk, the nature of the population, and the level of assurance the auditor is trying to obtain. Statistical sampling can sound intimidating at first because it introduces ideas like confidence, precision, and probability, but the underlying purpose is straightforward. The auditor wants a method that supports a defensible statement about the population based on the sample results, rather than relying entirely on intuition. If the auditor tests a properly selected statistical sample of approval records, the results can help estimate how likely it is that the broader population contains a certain level of deviation. This does not eliminate uncertainty, and no honest auditor should pretend otherwise, but it makes the uncertainty more visible and more structured. Terms like tolerable deviation and expected deviation become important because they help determine what sample size may be needed and what results the auditor can accept without concluding the control is too weak. For a beginner, the most useful way to think about statistical sampling is that it brings extra discipline to the relationship between the sample and the conclusion. It does not produce certainty, but it can strengthen the basis for the auditor's judgment when the situation calls for that level of formality. Sample size is one of the most misunderstood parts of methodology because people often assume there is a universal number that makes a sample strong. In reality, sample size depends on several factors, and those factors reflect the seriousness of the audit objective and the amount of risk the auditor is willing to accept. If the control being tested is very important, if the impact of failure is high, or if the auditor expects the process may contain problems, then a larger sample may be needed to achieve reasonable assurance. If the population is very consistent and the risk is lower, the sample may not need to be as large. Expected deviation also matters because when the auditor believes errors may already be present, the sample usually has to be larger to evaluate the issue properly. Population size matters too, though often less dramatically than beginners assume once the population reaches a certain scale. The main point is that sample size should be justified by audit logic, not chosen because it sounds convenient, traditional, or easy to complete before a deadline. The way items are selected is just as important as how many are selected, because a large sample chosen carelessly may be less reliable than a smaller sample chosen thoughtfully. Random selection is often favored when the goal is fairness and representativeness, because every item in the population has a meaningful chance of being included. Systematic selection can also be useful, such as selecting every 10th item after a random starting point, provided the population does not contain a hidden pattern that could distort the results. Judgmental selection may be appropriate in some cases, especially when the auditor wants to focus on high-risk items, unusual transactions, privileged accounts, or activities near reporting cutoffs. Block selection, where items from one short time period are tested together, is usually weaker for drawing broad conclusions because that cluster may not reflect the full population. A beginner should remember that selection method needs to match the purpose of the test. If the auditor wants to say something about the whole population, the sample should be chosen in a way that genuinely supports that kind of conclusion. After the sample is selected and the items are tested, the auditor has to interpret what the results actually mean, and this step requires judgment rather than simple box checking. If several sample items show missing approvals, late reviews, inaccurate entries, or unsupported access, the auditor cannot stop at counting the number of exceptions. The next question is whether those exceptions indicate isolated mistakes or a broader control problem in the population. The nature of the error matters, the frequency matters, and the cause matters. A control may appear mostly effective but suffer from a training weakness in one department, or it may show such a pattern of failure that the auditor can no longer rely on it at all. This is also where the idea of sampling risk becomes important. Because the auditor reviewed only a portion of the population, there is always some possibility that the sample does not perfectly reflect the larger set of items, which is why methodology and documentation must be strong enough to explain both the conclusion and its limits. It also helps to understand that not every exception has the same meaning, because audit results require context. One missing approval in a low-risk process may matter less than one inappropriate privileged access grant in a highly sensitive environment. Similarly, some deviations may be technical and minor, while others may point to a more serious weakness in oversight, system design, or management discipline. Auditors therefore look beyond the existence of an error and consider its significance, its root cause, and whether other controls may have reduced the harm. A sample result should lead the auditor into thoughtful analysis, not automatic reaction. That is why follow-up questions are often needed after exceptions appear. The auditor may need to expand testing, speak with process owners, compare the deviation to policy requirements, or evaluate whether the issue reflects a breakdown in control design, a breakdown in operation, or a failure in documentation that makes the process appear weaker than it actually is. Strong methodology supports this deeper reasoning rather than reducing everything to a simple pass or fail label. A practical example can make the topic easier to picture. Imagine an audit focused on user access approvals for a business application that handles sensitive customer data. The objective is to determine whether new access was approved by the appropriate manager and granted according to job responsibility during the last 12 months. The auditor first confirms what records make up the population, perhaps all completed access requests during that period, and then validates that the list is complete enough to support sampling. A sample is selected, and each chosen request is reviewed for evidence of approval, role appropriateness, and timely processing. If the auditor finds that most requests were handled correctly, but several lacked documented approval or showed access levels broader than the job required, that result may indicate more than routine paperwork mistakes. It may suggest weak oversight, poor role design, or a culture where access is granted quickly without sufficient scrutiny, all of which could increase real business risk far beyond the number of flawed samples alone. Common misconceptions can weaken both studying and real audit work, so it is worth clearing them up directly. One misconception is that a sample proves the entire population is perfect if no errors are found. In truth, the sample supports a conclusion about reasonable assurance, not absolute certainty, and honest auditors always recognize that limitation. Another misconception is that more samples automatically create better audits, but quantity without relevance, good population definition, and sound interpretation does not produce stronger assurance. A third misconception is that sampling is only about mathematics, when in fact the most important choices often involve understanding the process, defining the right population, matching the method to the objective, and interpreting the results in business context. Good documentation is also essential because the auditor should be able to explain how the population was defined, why the sample approach was chosen, what was tested, what exceptions were found, and how the final conclusion was reached. When documentation is weak, even careful testing becomes harder to trust, review, and defend later. As we close, the central idea to carry with you is that audit testing and sampling methodology are really about disciplined reasoning. Testing translates audit objectives into evidence, while sampling makes that evidence gathering practical in environments too large to examine item by item. Strong methodology depends on understanding the process, defining the right population, selecting items in a justifiable way, evaluating results thoughtfully, and being honest about what the evidence does and does not prove. For a CISA learner, this topic matters because it shows how auditors move from suspicion or curiosity to supportable conclusions that management can take seriously. When testing is well designed and sampling is well executed, the audit becomes more than a set of opinions. It becomes a structured evaluation built on evidence, judgment, and methods that are reliable enough to help an organization understand whether its controls are actually working.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.